Hi, welcome to the video lesson on solving quadratics by graphing. In this video, we are going to use the graphing calculator to solve quadratic equations. All right, so we've solved quadratics a couple of different ways so far, by factoring, by using the quadratic formula. All of those methods involved making sure one side was equal to zero. What we're trying to do is find the x values that when I plug it into the equation, the answer is equal to zero, that the y value is equal to zero. Well, on a graph, what that means is where the actual graph crosses the x-axis, where what x value when I plug it in is the height or the y value equal to zero. So in this case, we've got two solutions. One would be here at close to -4, and then over here at something that's a little less than zero. Now, a little bit of vocab, there's different terms for these, and they pop up a lot on MCAs and ACTs, and so we feel it's important that you know that there are these different terms for them so you don't get blindsided by it. We could call them solutions, roots, zeros, or x-intercepts. Quadratics is kind of a big thing in math, and it's test makers are really fond of like throwing out different ways to like ask the same question for whatever reason. So there's these four different terms that you could possibly see on some sort of a standardized test. All right, so how do we actually figure out where these zeros are using the graphing calculator? One thing, we got to use a little algebra and make sure one side is equal to zero first, just like you did with factoring and quadratic formula. We're going to use the y equals key in your graphing calculator, which is in the top left. We're going to use the second key, the trace button. I'll show you where that is, and then we're going to use that to find zeros. Once we get there, it's pretty much just follow the steps on your that it shows on the screen for the calculator. The little note down here, number of times the parabola crosses the x-axis is the number of solutions that that equation has. And if we look, if we go back here, this equation would have two solutions, right? Because it crosses it twice. Well, if I took this graph and I moved it up far enough, eventually the vertex would be right on the x-axis, and then it would only have one solution. And if I kept moving it up, eventually it would have no solutions because it wouldn't touch the x-axis at all. And that's something that we'll see later in this video. All right, so first problem, solve this by graphing. No algebra to do it first because it's already equal to zero. We can just start by plugging it into your calculator. So grab your calculator, bring it up on your computer, whatever, and follow along with me. All right, so hit the y equals button. So kind of follow my cursor here, y equals. If you have anything in there, clear it out. And we had x squared, so the variable key is right here next to the alpha key. And then the squared key is down here, kind of in the middle left. It was plus 4x, so plus 4, then back to the x key. And then it was -5. Now it's important here that you use the minus key and not the negative key. If you use the negative key, it's going to try to multiply by a -5. If you use the minus key, it's going to subtract 5. And obviously those are two different things, so one of them is right and one of them is wrong. All right, now click the graph button in the top right, and your graph should look like this. All right, we've got two zeros. One is right here, one is right here. Let's find them using the trace function. So use the second button, hit the trace key. The second is going to give us this calc menu. And we want to find a zero, so select the 2, 0, hit enter. And now notice a couple things have changed about our screen. I've got a little flashing cursor right here. That's where, like, I'm focused right now. That's this coordinate 0, -5. And it says left bound question mark. What I need to do is set a left bound by the 0 that I want to find. So I'm going to start with this 0 right here. So I'm going to move the cursor over close to it. And now I want to set a left bound. So I'm going to move a few clicks to the left of where the 0 is. So just get a few clicks, make sure that it's to the left, hit enter. Now it changed to say right bound question mark. So I want to set a right bound. I want to go to the right of the 0. So I want to go a few clicks to the right, hit enter. And now notice that my screen has these two vertical lines. What I have done is set a boundary to tell the calculator where to look for this 0. We can only see a small portion of this graph, but remember, this graph is infinite, and your graphing calculator can't look from infinity to infinity for zeros. It can also only look for 1 0 at a time. And so you need to tell it where to look. And so that's what I did here is I just set two boundaries and I said, start here, end here, tell me what 0 is between these two points. All right, so now this guess part doesn't matter at all, so just hit enter, and -5, 0 is our solution. Now -5 is the answer, not the 0, right? We just care about the x value that we're plugging in. All right, let's go ahead and find the next one then. So second trace, 0, scroll, move the cursor way over here. Now we want to be to the left, so get it close to the 0, move a few clicks to the left, hit enter, bring it back to close to the 0, go a few clicks to the right, hit enter. Guess doesn't matter, and 1 0, so x equals 1 is our second solution. And looking at the PowerPoint, x equals -5 and 1. Those are our two solutions. All right, pause the video, try this one. Notice this one's got a little work to do. We've got this -3, we got to move to the other side of the equation. So think, how do we do that? All right, we do that by adding 3 to both sides. And this is the equation that we actually want to put in the graphing calculator. So go back to our graphing calculator. Y equals, clear out the old formula. Now this one is -x². So in this case, we want to use the negative key, -x². And then the second term was a -3x. So now you're subtracting the 3x. So you do want to use that minus key. So -3x and +7. If you get an error when you're graphing, it's a really, really common error that somebody would accidentally use the minus key instead of a negative, or a negative instead of a minus, and sometimes that screws it up. I think it comes by as a syntax error or something like that. All right, if we graph it, upside down parabola, second trace, second trace, try that again, 0, come on. I'm getting a little laggy here. All right. And I'll start with the 0 that's to the left, so get close to it. A few clicks to the left, enter, get close to it, few clicks to the right, hit enter again, and -4.54. Now, if you notice over here, this y equals 1e to the -12. One limitation that your calculator has is it doesn't really find things exactly. It finds really, 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 really precise estimates. And so sometimes that estimate is off by just a minute amount. And so what this 1e -12 literally is scientific notation for 1 × 10 to the -12, which is a point, a bunch of zeros, and then a 1. And so it's basically for what we're doing, this is equal to 0. So -4.54 is our answer. The y value is actually 0. All right, so let's find the other one then. Try to get the cursor close to it, go a few clicks to the left, enter, right bound, few clicks to the right, enter, hit enter again, and 1.540. So -4.54 and 1.54 were our two answers. And I can confirm that if I check the PowerPoint. Does it agree? Yes, it does. -4.54 and 1.54. All right, pause, try this one on your own. Need to move this 8x over, so how do we do that? All right, we do that by subtracting 8x from both sides. this doesn't combine with the x squared or the 16, right? So this is what you should be entering in your calculator. So if we enter that one in our calculator, clear that out, x squared minus 8x plus 1, 6, graph it. This one looks like, no, did I, oh darn it, I didn't share my screen. All right, I'm not re-recording this. There we go. All right, so there's the equation that you should enter, graph it, and it should look like this. I didn't realize I didn't have my calculator screen shared, and that's the third time I've done it, so I'm not re-recording this. The second trace, 0. Now we've only got 1 0 to look for this time, it looks like. With this, I can't see where my cursor is, okay? But if I look down here, x equals 0, y equals 16. Those are the coordinates of where the cursor actually is on the screen. So if I think about where that point would be on the screen, the x value is 0, so it's 0 left and right, and then it's up 16, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16 is probably up here somewhere. And so I can think, I can move this cursor left and right, and it's just going to follow where the graph actually is. So obviously, I want to move it from where my mouse cursor is here down to here. That's moving to the right. So if I start clicking to the right, eventually it'll show up, and it did. But you can use that sometimes to find a missing cursor. Okay, so left bound, there's pretty close to the 0, so we'll back it up to the left a few clicks. Enter, move it this way a few clicks, enter, hit enter again. And here's another example of your calculator trying to make a really good estimate and coming up with something that's just a little off. 4.00000027. This is 4. We're gonna round to 2 decimal places, so it would round to 4 anyway, but this is equal to 4. It could also come up as 3.9999999 something. That's equal to 4. All right. So let's double check with the PowerPoint and see if that agrees. And it's x equals 4. We did it right. Good. All right, last one. This one, okay, I don't have an animation in here. It's no real solution, but here's why. Let's plug it into the graphing calculator and just see why. All right, so y equals x squared minus 3x plus 5. Graph it. And the graph looks like this. It does not hit the x-axis. Now, if this happens, it's worth double checking that you entered it in correctly, that you entered it here correctly. And if you did, then, and it still looks like this and it doesn't cross the x-axis anywhere, that means it's no real solutions. Okay, so that is it. There is the homework worksheet with a key plus a Canvas quiz. Should be pretty standard by now. If you have any questions, take a screenshot, shoot it to your teacher, post something on a discussion board if your teacher has that up, or log on during a video conference, and we'll try to answer any questions that you have.